So we're going to talk about piecewise functions a little bit. I want you to first remember what a piecewise function looks like as far as the graph is concerned. Basically, there's two pieces. It might not connect. It might look something like this and then happen to connect. It could have more than one piece. It could have three pieces. Those are basically piecewise functions. Now, if I'm thinking about the limit of the piecewise functions, at the place where they where the pieces connect, basically what I'm thinking about when I'm thinking about those limits is what's going on to the left and right of that place. So if this is x equals 2, I notice that the limit as x approaches 2 is undefined because on one piece it's going somewhere and on the other piece it's going somewhere else. On this one, if that was x equals 2, the limit would be whatever this dot is because on both places they're both going towards that dot. So with piecewise functions, you're kind of looking at the two different pieces and trying to decide, okay, what are those two pieces doing? So basically, if I say find the limit as x approaches 2, well, I'm going to have to figure out what the limit is on the left side of 2, and I'm going to have to figure out the limit on the right side of 2, and then I could compare to figure out the limit as I approach 2. So let's look at some examples. Let's say that I want to find the limit of this function. So let's find the limit as you approach 1. So what I was saying about the graph, you don't really have to know what the graph looks like here in order to figure out the limit, but if you kind of understand what's going on with the graph, that kind of helps you with the limit. So this is a line, x plus 2, here's 1. So x plus 2 is a line going through 2, and at 1 that would be 3. Because if you plug in a 1, you get 3. The other one is a line at 3, like a horizontal line, for x is greater than 1, so it would look something like that. Now again, you don't really have to know how to graph it per se, but if you can understand a little bit about it, it helps you understand how to find the limit. By looking at this, I can tell that the limit is going to exist, and the limit as I approach 1 is 3. Now basically what happened here, and the way I figured it out, is I found the limit as you approach 1 from the left, and the left would be to the left of 1 or less than 1. So I'm just plugging in 1 in that first one, and I get 3. And then if I find the limit as x approaches 1 from the right, that would be x is greater than 1, which is this part here. And I'm just plugging it in, I get 3. And I notice that both the one from the left and one from the right are 3, so that must mean that the limit itself is 3. Alright, here's another one. Again, I really don't need to know the way the graph looks. I need to just sort of understand what's going on. I know that I have a parabola and then a line, and somehow the parabola and the line are both parts of this function. Again, I'm not sure if they connect or not, or if they're not connected, but the way that I can tell is by plugging in 0 into the first one and 0 into the second one. So basically I'm finding the limit as x approaches 0 from the right and 0 from the left. And the limit for 0 from the right would be x is greater than 0 would be 3, because I'm plugging in 0 to that. And then 0, and I wrote that the wrong place, I'm sorry. I said 0 from the right. And then 0 from the left would be the first one, and you're just plugging in a 0. Notice that 0 from the right and 0 from the left are different. That means that they do not connect, which means that the limit as you approach 0 is undefined. So basically you're just trying to figure out with these piecewise functions if they connect or if they don't. Now if they ask me something like these two about x approaching 1 and x approaching negative 2, because this is true for all x is less than 0, and that's a parabola, well at negative 2, I know it's just a parabola, so it's just whatever the y value is at 2. Since it's negative 2 and negative 2 is less than 0, I just plug it in there. I would have negative 2 squared minus 3. And that would be negative 2 squared is 4, put the negative on it, subtract 3, so that would be negative 7. As x approaches 1, I know that 1 is greater than or equal to 0. I know I'm plugging it into the line, so I just plug it in. I know that I just need the y value, which is 4. The only time you really have to check both sides is when you're approaching the place where the piecewise function may or may not connect. Alright, on this one. This one's kind of strange because if I'm wanting the limit as I approach 2, basically I need to plug 2 into each equation. Well, the bottom equation is pretty easy. So the limit as x approaches 2 from the right would be 1/3 times 2 minus a third, which is 2/3 minus a third, which is 1/3. But from the left, it's a little different here because if I just plug in the 2, I'm going to get 0 over 0. So I have to think about my other processes, and I can factor there. And if I factor the bottom, I get x minus 2, x plus 1. Those will go away, so now I have the limit as x approaches 2 from the left of 1 over x plus 1. And now when I plug a 2 into there, I get 1/3. Well, from the right and from the left, I both get 1/3. So the limit as I approach 2 is 1/3. So technically, when I'm doing a problem like this, I'm having to find the limit from the right and left first before I can do that, because with piecewise functions we're looking at those two different pieces. If they would have been different, the answer would have been undefined. Alright. So plugging in 0 here, if I do the limit as x approaches 2 from the right, that's the bottom part of it, I get 0. If I do the limit as x approaches 2 from the left, it looks like a factoring problem, and then you sort of work it out from there. But what you will notice is you can go ahead and plug in a 0 for x, and you would get negative 4 over negative 2. And I've already realized that this was not correct. This should have been 0. Sorry about that, guys. Limit as x approaches 0 from the right, and limit as x approaches 0 from the left. So let's go back to that first one. 0 from the right, I'm plugging it into here. That should be negative 2. Alright, plugging 0 into the first one, I was doing that correctly. I do get negative 4 over negative 2, which is positive 2. And so one side of the function is approaching negative 2, the other side is approaching positive 2. That means that the limit of f of x as you approach 0 does not exist. I could have factored this and then worked it out, but because it was okay to just plug in 0 and I didn't get anything strange on the bottom, that was okay for me just to plug it in. Alright, this one's a little different because it says x is not equal to 0 and x equals 0. And piecewise functions like that usually include a hole. So it might be a line with a hole, and then the x equals 0 and 4, it might either fill in the hole or put a hole somewhere else. So really the question is, am I filling in the hole, or is the hole somewhere else, sort of like this problem? Honestly, it really doesn't matter whether you're filling in the hole or not, because if I filled in the hole, the point would intersect with the graph. The limit, whether I fill in the hole or not, is still whatever I'm approaching, regardless of what the f of x value going to be. So this run right here really is not concerning to us. It matters if I said what is f of 0. Well, f of 0 is 4. But if I'm talking about the limit, the important part for the limit is this first part. And so I just plug in 0, I plug in 1, and I plug in 2. I will tell you, if I think about the graph, that's x squared right there, and it says x squared everywhere except 0. So it would probably look sort of like that, and then there would be a point up here at 0, 4. And as far as the limit's concerned, that point really makes no difference in the graph. Alright, last example on this kind. Let's say I wanted to find the limit as x approaches 2. It's similar to the last one. Still, it looks like because it says x is not equal to 2 and x equals 2, there's still probably a hole or of some sort. So I'm just trying to figure out, do I fill in the hole or do I not? I can't just plug in 2 in that first equation, but if I sort of reduce a little bit and end up with 1 over x, I can plug in a 2, and then I get 1/2. Well, 1/2 is the limit. And what that means is there is a hole at 1/2, and then below that at negative 1/2 is where the point is actually filled in. Alright, there's one more type of problem I want to show you, and this problem involves a formula. And it goes like this: the limit as h approaches 0 of f of x plus h minus f of x over h. On these problems, I'm just going to give you that particular formula, and you're just going to have to use that formula to solve problems. Eventually, I'm going to explain to you that this formula is a really important formula and that it really does mean something, but at this point we're just talking about how you solve the formula. So your first problem is f of x equals 4 minus 3x. And what this is asking me to find is the limit of this whole thing. So in order for me to do this, I also need to know what f of x plus h is. And this is sort of something from like algebra or pre-calculus. You take this x plus h and you plug it in for x. So I get 4 minus 3 times x plus h. You can go ahead and work that out if you want to. Alright. Now I'm just going to use that formula up here and I'm going to plug in what I know. So I'm trying to find the limit as h approaches 0. F of x plus h is what we just found here. Minus f of x. Well, that's f of x. Be careful about that minus. It does go to both pieces. And then all over h. So basically I figure out f of x, I figure out f of x plus h, and then I plug them in here and here. Alright, now to finish the problem, you've been doing problems like this. H is sort of like your delta x, it's just written as h. Keep in mind that this is negative 4 and positive 3x. So the 4's will go away. Positive 3x will go away with that. I end up with negative 3h over h, which is negative 3. And then that's the answer. There's nowhere to plug that 0 in. We're going to continue using this formula here on the rest of the problems. Let's say that we have f of x equals, so I just realized this should be problem 8 and that last problem should be problem 7. I just wrote that wrong, but if you're trying to follow along with me, that will help you. So problem 8 is f of x equals the square root of x plus 3. Alright, next thing I want to do, so this is the actual problem that you'll be given, and you'll be given that other formula. So then first thing you need to do is find f of x plus h. That just means take x plus h and plug it in for x. So you get x plus h plus 3. Alright, now if I do the formula, I have the limit as h approaches 0 of f of x plus h, so of that, minus f of x, which is that, all over h. And then now you're down to a conjugate problem. It looks yucky because it has several variables, but that's what's going on here. So we have square root of x plus h plus 3 plus square root of x plus 3. Notice you had to change that sign. Alright, then we multiply that and that. Multiply that and that. There is a minus in between, so it's minus x plus 3. Inside and outside cancel. Alright, so then we have the x's will cancel. That's a minus x. That's a 3 and a minus 3. All we have left on top is a h. The h will cancel with that h. So really there's just a 1 on top. H will be 0. So we have, that's a plus, so this should be a plus, I'm sorry. So we have the square root of x plus 3 plus the square root of x plus 3. You can write that as 1 over 2 square root of x plus 3, or you can just leave it like that. Okay, I've got one more problem I want to show you. Alright, I need to figure out what f of x plus h is. I plug x plus h into both places on the x formula. And the tricky part here is that I'm going to have to square that and then multiply by 2. I'm just going to tell you that's x squared plus 2xh plus h squared if you square it out. And then I'm going to multiply by the negative 2, so we have negative 2x squared minus 4xh minus 2h squared. So now if I do my formula, the limit as h approaches 0 of f of x plus h, which is all that, minus f of x, which is all that. It was a minus, that's the reason I changed that sign right there, all over h. Alright, what things can cancel here that we have? That should have been just an x, not an x squared. Alright, x's will go away. 2x squareds go away. So I'm left with negative 4xh minus 2h squared over h. Factor out a h like we've done before. Plug in your 0. And I messed up again. I'm so very, very, very sorry. I left off this h right here. So there's an h at the beginning. When I factor out a h, there's a 1 there. Don't forget that. So I'm left with 1 minus 4x. Alright, here's the try problems. I'm sorry the video is as long as it is. I really intended it to be shorter, but I guess I started talking too much. So 1, 2, and 3 are like piecewise functions that you're trying to find those limits, and then the last one is that strange formula that you're going to be using to find the limit of f of x equals x squared plus 1.